Good afternoon, everyone, and welcome to the Construction Specifiers demo cast on thermal and acoustical insulation, understanding vapor and thermal barriers by International Cellulose Corporation. My name is Nitya, and I'll be moderating today's presentation. Before I introduce the speaker, please note your mics are muted. It would be best if you turn on the speaker view. That said, if you have any questions for our speaker, feel free to post them in the Q&A forum. We will address as many questions as possible at the end of the presentation. If you have any connectivity or Zoom related questions, you can use the chat feature to communicate with us, and we'll do our best to help you. Today's presentation is being recorded. It will be available on the Construction Specifiers website, so you can access it whenever you need to. Now, I'd like to introduce our speaker. Brian Straw, CSI, is Regional Sales Manager at International Cellulose Corporation. In today's presentation, Brian will explain the differences in acoustical and thermal insulation products. With that, I'll turn things over to Brian.
Well, thank you very much, and I appreciate everybody who's signed up for the workshop today. Hopefully, you'll get as much out of this as possible. I will admit this: I'm not a scientist, and I don't have any science background. So when it comes to vapor barriers and trying to basically answer every question that may come under the sun or that you may have today, I'm not sure I can do that, but I'll do the best I can. And I'm going to try to kind of go through this as quickly as I can, just so that we can spend as much time in the Q&A session as possible. As she had mentioned, I work for a company called International Cellulose Corporation. We manufacture spray applied thermal and acoustical insulation. And so hopefully I can get to some of that within today's presentation as well. But we'll start with this: vapor barriers. And a vapor barrier is basically intended to stop the flow of water vapor from one place to another. So, you're in a house and you want to keep it from going into the building assembly or whatever it may be. But that is basically the object of a vapor barrier, right? We've all heard about it, but we're trying to prevent water vapor from moving from one space to the other. The important thing to kind of keep in mind, at least to me, is to get an understanding of vapor barriers is that you're going to apply that vapor barrier to the warm side of a building. So if we use this example right here, we have kind of the typical, wall assembly for a residential home. And it looks like it's a cold day outside. It's only 10 degrees on that thermometer on the right. On the left is the inside of the home, where it's what looks like it's about 70 degrees right now. And so what you have is you're looking to keep the water vapor from the warm side, that inside this house in this example, from getting into the wall assembly, where if it hits that cold air, it's going to basically drop the water molecules in that air molecule and liquefy. That water vapor is going to turn into water, and then you see the mess that you've got an example right there. The best demonstration I can come up with regard to a vapor barrier, or the need for a vapor barrier, and how water vapor works is really a soda glass just like this. It's you got ice Coke inside the glass, and it's a nice warm day on the outside. And so what we're used to seeing is what? Water molecules or water vapor, water drops form on the outside of that glass. And so the water vapor isn't necessarily, it's not like it's water, cold Coke leaching through the glass. What it is that there's air on the outside of the glass that's warmer than the glass, right? And it carries water molecules in that air. When it gets cold enough, it drops that water molecule, and that turns into liquid water, right? And so that's what you're seeing basically applied here to the outside of that glass, is the warm water hitting that cold surface. Those air molecules drop it, and then they let it go. Another example would be a cup of coffee right here. You've got a hot coffee, and then so the temperature in the room is cooler than that. And so as you can see with the napkin, the outside is where that water is going to drop, that air is going to leave that water alone, drop it off, and then you've got water on the outside of that napkin. But basically you've got a four-fold napkin, right? Thank you. Thank you for Subway for sponsoring this portion of the democast. But as you notice, no other water vapors anywhere else in the napkin, only on the top. So it was only releasing the water. The air molecules were only releasing that water vapor when they hit that cold surface. And in this case, cold temperature of the room being colder than the coffee. So hopefully that kind of clears everything up as far as how vapors work. When it comes to needing a water vapor or vapor barrier, you're going to be classified into one of essentially three different types of retarders. And then class 1 is obviously the most important. And a perm is what they basically measure that is. And a perm is 1 grain of water vapor per hour per square foot of material per inch of mercury. So there's your definition of what the water vapor is. And the object obviously is to prevent the water from getting into the assemblies. But the problem is when water does get in, you want to be able to let it get out, right? And this is an issue because, you know, water vapor, if you're going to prevent it and put it on that inside of that house, it's going to do just as good a job as basically keeping the water in, whatever water gets in, as it is as retarding the water from getting in the first place. And even any class 1 vapor retarder is basically going to leave in the wall assembly somewhere. That 0.1 perm will end up being about 5 ounces of water in a typical wall assembly in a typical, you know, a cold home in the winter, right? If you have just a 1 inch square, in that water vapor, so that's where nail holes went, or there's, you know, space around sockets, things like that. A 1 inch square is going to allow about 4 gallons of water into that wall assembly, a typical wall assembly in a typical winter in the north. So it lets in a lot of water vapor. So what you want is you want to try to keep out as much water vapor as you possibly can, obviously, but you want to be able to let it get out if it can get in. And so you may not always need a vapor barrier, I guess is the point of all this. And this is what I've been able to conclude based on my, you know, knowledge and education. You consider vapor barriers in a couple different regions. Obviously in the northern regions, say in this, you've got different climate zones. I would say 5, 6, and 7 obviously are going to consider vapor barriers in the winter, right? And then zones 1 and 2 may consider them or may have a need for them in the summer. You know, in Miami, it's very hot, obviously. And so you have a situation where you've got a cool space above and you may need a vapor barrier. Now, when it comes to our material, again, we're basically a spray applied, in this case, thermal insulation. That would be the applicable products with regard to vapor barrier situations. Then in those zones 5, 6, 7, and 8, you don't really have to concern yourself with a vapor barrier and our material. And the reason being that vapor barrier would have to be on the inside of the building or the warm side of the building. In the south, let's say, that's a good example of where our material would be applied and you might have a need for a vapor barrier. So we're in South Florida, right? It's a warm climate outside and we've got a cold occupied space. So it's a hospital, as you can see there, you've got computer or mechanical rooms or refrigeration facilities, right? And then you've got the space beneath where you've got air being able to come in and cause a problem and cause a vapor barrier. So you might need it between the parking structure, let's say, and the occupied space of this hospital above, because they keep the temperatures about, you know, 60 degrees, something like that. And so if it's 95 every day, you've got a big difference in temperature, right? And so in those kinds of applications, thermal application that we use is very popular in these types of situations, is something we make that's called Ure-K. And what Ure-K is designed to do is to go over and protect any closed cell foam or any spray foam actually, but in closed cell foam. And the reason we would use a closed cell foam, or a closed cell foam is very popular in this kind of application, is because it does provide a vapor barrier. So if we're in South Florida and we've got an operating room above us at 55 degrees or 60 degrees, whatever the doctor wants to keep it at, and it's 95, then we might need a vapor barrier to protect that thing. And we would need it on the warm side, which would be the outside of this situation. Now, the problem with spray polyurethane foam, it works very good. I can understand the need for closed cell foam because, again, it provides a vapor barrier. Open cell foam, not so much. But spray polyurethane foam creates a black smoke. It creates combustible gases that can create flashover, in which the entire fuel assembly, all that foam would go up because it's all liquid fuel, and it has some toxic chemicals involved in it. So you can't spray polyurethane foam, open cell, closed cell, whatever it may be, in an inhabited space. You have to use what is basically considered and what's defined as a thermal barrier. So for those of you who joined today and we're hoping thermal barrier was going to talk a lot about you know, thermal insulation. Obviously, it does apply in this application. We're using it for closed cell foam, but a thermal barrier is just basically a material that's applied that will basically coat that polyurethane foam or that plastic and protect the interior spaces, the livable spaces from a fire, you know, in the event of a fire. And the reason is it's going to prevent the temperature rise of that foam. So it's not only going to keep it from burning, it's going to prevent it from actually rising in temperature. And so that brings up, with regard to thermal barrier, the difference between an ignition barrier and a thermal barrier in these types of situations. An ignition barrier, if I had basically a Bic lighter and I took it to a piece of fiberglass, could I light that fiberglass on fire? And the answer would be no. And that's why it's okay as an ignition barrier. And that's why you see it in places like crawl spaces or attics where there's not a lot of ventilation, there's not much going on, you're not storing things in there, and all you're looking to do is prevent that material from catching on fire from an actual flame. And that is what they consider, as you see basically in that first banner, a 5-minute egress, 5 minutes before the place is likely to go up. A thermal barrier is different. It is a 15-minute egress, so it's giving you 15 minutes, and it's not only preventing, let's say, you taking that flame and lighting that material on fire, it's also preventing the heat from getting hot enough for that to combust. And that's the difference between a thermal barrier and then an ignition barrier. And so when it comes to closed cell foam applications, what I hope you will consider, because you will need a thermal barrier, is our Ure-K product. And the reason for that is that I don't necessarily have a problem with an incandescent paint or DC315, which is a very popular application for going over these closed cell foams. It's not that that manufactured product is necessarily flawed, or in any case there's anything wrong with it. It's just that it's only as strong as the weakest point of that application. It's spray applied. So anytime you've painted a room and you've come back the next day and thought, I missed a spot. Well, if you're doing that with an incandescent paint to protect your closed cell foam or your open cell foam, then you're going to run into a problem. We had that kind of situation here in Houston, Texas 4 years ago. It was basically election day, and a car fire started in a parking garage. And by the way, car fires are the #1 reason fire departments are called to fires. Well, it took from the time that woman smelled smoke in her car to where the fire out of the car caught the ceiling on fire. That took, as you see, about 5 minutes and 40 seconds. In less than 30 seconds, the rest of the place went up, because that's that flashover. Once it caught fire, the entire foam on the ceiling is a fuel source. And so that's what you're seeing. That's a 450 smoke development, right? So that's your class 1, class A situation. It's a very difficult situation. You wouldn't want it. Ure-K is applied at 1.25 inch application. Right? So it's a thicker application. It's going to be protected. You don't want to deal with this. Again, that's 450 smoke development. That's class 1, class A. Ure-K has been safe enough that it's been used in a number of different firehouses across the United States as safe to go over foam. It's in a children's museum in upstate New York as safe to go over foam. And it actually gives you the added bonus that an incandescent paint would, in that it has an R value of 4.5. So if it's a thermal application, you get a little bang for your buck there. And then when it comes to an indoor, let's say an acoustic application, like you see here, it's got an NRC of 0.95. So it's absorbing most of the unwanted, almost all of the unwanted echo and reverberation in the room. And so when we go back to vapor barriers, right, these are the applications, parking structures, things like that, where our thermal insulation is often used. And in this kind of situation, we saw when we needed a vapor barrier, Ure-K is an outstanding application. But the fact of the matter is, most of the time, a vapor barrier isn't required. And so what is used is our K-13 application. And so you've got a parking structure, and now we can be up in Boston, and you've got that occupied space above. Well, the K-13 can work as an insulation. There's no vapor barrier required between the parking structure and the occupied space above. And then when it comes to acoustic applications, really there's no spot in that occupied space above the parking garage where people aren't using our product, whether it be restaurants or retail spaces. Restaurants in particular, the noise in restaurants is obviously very, very loud. It's basically about 15 decibels louder than a normal conversation. And when you consider just a 10 decibel increase is perceived by the listener as that sound's having doubled, restaurants obviously have a lot of issues. So do offices and hotels, apartments. We understand all those kinds of in-office applications of our acoustic materials, both K-13, Sonospray, and Sonocrete. And so I just realized right now I've basically told you all about our products and haven't even introduced ourselves. As I mentioned, I work for International Cellulose Corporation. I said that at the top. We manufacture spray applied thermal and acoustical insulations under the name of a number of different headings. I guess we're the InBev or Anheuser-Busch of the spray applied natural fiber-based spray applied thermal insulation business. We are based in Houston, Texas. That is where our factory and our manufacturing facility is. And so what that means is every bag of material is going to be manufactured in the same place. So whether it's going to a job somewhere in the United States or somewhere across the globe, it is going to be manufactured with the same high quality and the same high standards in the same manufacturing facility in Houston, Texas. And we've been respected because of the high quality we have. We've had an underwriter label laboratory label on every bag of our material continuously since 1966. We are an ISO 9001 registered company, so we adhere to some of the highest quality standards in the world. And insurance companies like Factory Mutual love us as well. We've been doing field and follow-up testing with Factory Mutual since 1974. They actually have higher standards than UL, and we have never failed a test, and they have never had a claim against our material. What I like most about our material is how green it is. It's not that we have a low carbon footprint. Our material actually sequesters carbon, which is why it is a M1 classified low emission building material. All our manufactured products are Green Guard Gold certified, and they're listed in the Mindful Materials Library, as well as this Sustainable Minds Transparency Catalog. And all our materials come with both an environmental and a health product declaration. There are no red list chemicals. There are no hydrofluorocarbons used in either the manufacturing, application, or afterlife of the product. It's applied using a water-based low VOC adhesive, so there's nothing to hurt anybody in the environment or the environment itself. And perhaps best of all, mold and mildew cannot grow in our material. Bugs can't go in it either, but that's, I guess, a conversation for another day. And I know I've already told you about this, so I buried the lead, but K-13 and Ure-K are our thermal application as far as spray applied insulation. Ure-K, of course, designed to go over spray foam. And then from an acoustic application, both K-13 and Ure-K provide acoustic applications, and then SonaSpray and SonaCrete are specifically designed for acoustic applications. Our materials, K-13 and SonaSpray, come in a number of different standard colors. Ure-K and SonaCrete come in white, and when it comes to the standard colors, honestly, right now, I would say gray is probably one of the more popular applications, whether it be light gray or regular gray. And I would say this when it comes to a parking structure, specify it in gray or light gray. For the same reason you don't walk on white carpet very often, you don't really want a white ceiling in a parking garage where there's going to be a lot of dirt, and white shows dirt. Gray, as you probably realized by the last time you went out walking someplace and noticed you were on a gray carpet, does a lot better job of hiding it. And then when it comes to a standard color, black has always been a very popular color. Here you see it obviously as an acoustic application at America's Test Kitchen. So you got it at a TV studio right there, again, highlighting the outstanding acoustic properties of the material. Now, all our materials also come in custom colors. So if you've got a custom color you want, send us the Sherwin-Williams paint swatch, or give us the code number, and we will make a sample of the material for you. And you will actually approve the color of your material, basically the fibers, before we go ahead and commit the manufacturing of your order for you. But whether it's red or midnight blue or purple, or in this case at the Rosewood Hotel, what they wanted to do was match the color of the woodwork, and I think we did a pretty good job with that. And according to people who have been there, it looks a lot like suede. So you've got that going for you. Now, there are a couple of differences, I think, between our material and probably our most common competition, which would be spray applied fiberglass. And one of those, I think, to me, is in fire endurance. Now, we all see the E84 test, right? When we're putting in a specification, that's usually what we're recommending is the E84. You've got to be able to pass that. And it's a flame spread and smoke development test. And so we certainly understand. We saw what the 450 smoke development looked like. Nobody wants to be there. Well, as you can see, all our materials are Class 1, Class A rated with a flame spread of 5 and a smoke development of 5, with the exception of SonaCrete, which has a smoke development of 10. In fact, our material is so safe, it's in a number of different UL design assemblies as safe to go over fireproofing. Both K-13 and SonaSpray, you can get the design assemblies on the UL website or at our website and basically download and go from there if you wanted to. And as you see, Class 1, Class A is a flame spread of less than 25 and a smoke development of less than 450. And even though we have a combustible product, our material will not melt. It will not char, it will not burn either. It will char, but it will not melt. And the reason I bring that up is because I think this is also a very important test, or a very important indication of fire endurance. And that is what is called an E119 test procedure, in which they take your material, they subject it to up to 1500 degree temperatures for a 30-minute period of time and see how well your material basically survives. This is a comparison between our material K-13 and spray applied fiberglass. Well, it's a dramatization of it and basically kind of a key point in the test.
At 10 minutes, the temperature of the fire is 1,299 degrees Fahrenheit. K-13's internal temperature is 171 degrees. The sprayed fiberglass is 532 degrees. K-13 remains in place. The sprayed fiberglass begins to melt and drip. Minutes later, the K-13 internal temperature sensor reads 283 degrees, and the K-13 remains in place, protecting the substrate. The sprayed fiberglass has completely melted from the substrate, leaving the gypsum board exposed.
And so if we go back to some of those fire requirements or fire things, again, you know, an ignition barrier, a 5-minute barrier, that's essentially what the fiberglass, it's not that it combusted, but it started to melt basically within 5 minutes or within 7 minutes, and within 17 minutes, it was completely gone. On the other side, you see our material. Yes, it did char, but it's still there protecting the substrate and therefore protecting all the inhabitants down below, because it didn't allow anything to happen. Not only, honestly, on a 30-minute test did the fiberglass completely melt away, but you do see damage to the drywall or the gypsum board basically in the space. So you even saw damage to a 1-hour fire rated material. The other thing that I think is a big difference between our material and spray applied fiberglass, and look, I understand that it's often we're competing against that, you know, in parking structures and things like that, because the R value is very similar and the acoustic values are very similar. But I think the fire endurance is completely different, and I think the bond strength is completely different. This is an example of a test where essentially what they do is they come and they glue one pound hooks to your material. They wait 24 hours, come back, and they see how much weight it's going to take to pull that material from your or the hook from your material. Well, we tested one not too long ago, obviously, here in Houston, Texas, that was almost a 30-year-old project, right? So that's almost 30 years of heat and humidity in Houston, multiple floods, multiple hurricanes, and it still tested at a bond strength of greater than 375 pounds per square foot. Once properly applied, the material isn't going to go anywhere. We went down the street and tested a spray applied fiberglass application in a parking structure. And so not only gluing it, but duct taping it, they couldn't even get the 1 pound hook to adhere to the material. So it's basically had a bond strength of less than 1 pound. And again, once it goes up, you want it to be able to stay up. At least I think so. Now, in specifications, when it comes to downloading the specs, so to speak, to use K-13 in our material, we've got a bond strength. We use the bond strength of greater than 100 pounds per square foot. But even though you saw, as it was, almost a 30-year-old application with a bond strength of greater than 375. For Sona Spray, it's a bond strength of greater than 600 pounds. For Sonacrete, it's greater than 800 pounds. And under test conditions, so you got to assume these are the best case conditions, spray applied fiberglass has a maximum bond strength of 43 pounds per square foot. And so this is what you end up with, or this is what you potentially could end up with some wind damage, is what you're seeing in a parking structure in Austin, Texas. That's not a couple inches of fresh snow in Chicago, that's wind damage, and that's your spray applied fiberglass on the floor in Austin, Texas. Because we have such a great adhesive system, it allows us to do things with K-13 when it comes to thermal applications, and to go all the way to an R38. And we call this basically a K-13 high R application. And what you see is they can apply up to 5 inches of the K-13, come back and put in a memoryless wire mesh, and then go up again to another 5 inches. Here's an application you see at the Apple retail store in Providence, Rhode Island. And the interesting thing about that is Simon basically is the one managing that mall. So they're the ones paying the utilities. Well, they were saving so much money on the cost of the utilities underneath the Apple store that they went in and did the rest of the parking structure and replaced whatever was the insulation and put in K-13 in a high R system to kind of save on energy costs. So it really can make a difference. And for those of you who don't know R value, that's basically the measure of heat resistance or heat flow. And that's what we determine how good an insulation product is. Now, the one thing I will keep in mind, if you look at this little chart here, so you got an R value from 8 to 12 and 12 to 16, 20 to 32. It's not necessarily that you see a huge jump in the additional amount of R value and the additional amount of reduction of heat flow. In fact, if you look at like at 20, at an R value of 20, you're reducing 96% of that heat flow. At 32, so an extra 12 in the R value, and you've only gone up 1%. So something to keep in mind there. And again, from thermal products, K-13 has an R value of 3.75 per inch and can go all the way up to the R38, as you saw. And as we've mentioned earlier, I guess I should say, the R value of the Ure-K in that 1 1/4 inch application is 4.5, and then it has the overall NRC of 0.95. So where you're looking, as you see an application in Boston, or whether it's in Waco, Texas, and you're not necessarily concerned with needing a vapor barrier, our material is a very green way to provide your thermal barrier and thermal protection. So I've tried to save as much time as I can for any questions that you may have, and I will be honest, I'll do the best I can, but if I can't answer your question and you want it answered, just send me an email. It's at bstraw@spray-on.com, and I'll make sure I get an answer for you. So without further ado, I turn it back over to y'all.
Thanks, Brian. We do have some questions, and participants, if you have any questions, please post them in the Q&A forum, and I will ask Brian to address them. So Brian, the first question coming our way: what would be the thickness of the thermal insulation in a parking application?
It's going to depend on the R value that you need. I'll be honest with you. I would say 10, 15, even as recent as maybe 5 years ago, often it was probably 2 or 3 inches of K-13 and you were getting an R value of probably somewhere in the neighborhood of 10 to 15. That's what you were shooting for. I do hear at least people coming to me, architects or general contractors and our licensed contractors saying they're looking for R30s. Well, in a situation like that, that would require kind of what you saw at the Apple store, which would be a high R application because you'd be needing about 8, 9 inches of R material. And then whether it be let's say a closed or open cell foam, well, open cell foam isn't really good because the R value isn't even as high as us or sprayed fiberglass. But if you needed an R30, you could use a closed cell foam, and that would probably get you an R value of about 5.5, maybe 6 per inch, where we're at 3 3/4 per inch. So it's going to depend on what R value you're looking for.
Thank you, Brian. And the next question is the sound insulation spray applied material. The question is, will it adhere well to an already painted concrete ceiling?
Yes, it will. It'll adhere to that concrete. The thing about our material and the adhesive system, what I would say, or what I say is if you can put a latex or a water-based paint, if you could paint it with that, our material would adhere to it. So it's almost any clean substrate it will adhere to.
Okay, got it. The next question is, what are all the factors that impact the square foot applied cost?
Honestly, the setup and the cleanup for people applying our material. It's very similar, again, because it's spray applied, it's almost like somebody was painting that room. So consider if in other words, let's say they're doing the ceiling, but they don't want to do the support or the support beams or something like that, then that either needs to be taped up on the front end or cleaned up. So a lot of it has to do with how clean the room is and how ready it is to be prepared and to be done. And that, because the labor is the only other major cost. And honestly, the labor is probably higher than, not probably, it is higher than the material, but that, you understand that. But it's best if, let's say it was new construction, that there isn't any HVAC work for them to work around. Whatever the hooks or hangers are, they're already applied. That would be a great advantage, obviously, so that somebody doesn't have to go back in and go through your material or through the insulation. But as long as everything's hooked and then there isn't anything basically hanging, obviously it makes it a lot easier, so that reduces your cost.
Okay. Thank you, Brian. And the next question is, somebody wants to know if how your product can be purchased. I assume the best way would be for them to email you at the email ID that you provided.
They can do that. And
okay.
The only way, I guess I should say, that people can get our material is through one of our licensed contractors. And that allows us to make sure that you're getting as high quality in application as you are as regard to the material and the manufacturing of the product we make. They're trained by us, they're using our equipment. So the licensed contractors are going to do the best job. And they're the ones who are actually going to sell it. And they're going to know the size and space of the scope. And so they can give you an accurate price as far as price per square foot too.
Thank you, Brian. The next question, is there a hardener for the cellulose insulation? Like an additive, probably?
Is there a what now?
A hardener. A hardener. H-A-R-D-E-N-E-R, a hardener?
Yes, there is. We make a product called Ure-K.
Okay.
Which, you can apply, and it is applied sometimes and actually there's we have another product as well, but we do have some products for like in parking structures, if you were worried about antennas scraping the ceiling or something like that. Yes, there is. But otherwise, honestly, just as a standalone product, you're not going to have dandruff and you're not going to have flaking. So that won't be an issue for you.
Okay, thank you. The next question, can your products be applied under a raised floor?
Yes, it can. Again, it depends on no matter what the substrate of the floor is, let's say it's a raised wood floor, then certainly that material can be applied beneath it. Yeah.
Okay. Thank you.
There are applications where it's happened, I know of.
Okay. Thanks, Brian. The next question, what about cleanup? How easy or hard is it to remove the material once applied?
It's going to be difficult because of the bond strength of the material. So it's not going to come down easy. The best example I can have is it was in the old, and I know this is a really dated reference, but it was in the Seattle Kingdom. Initially there was asbestos panels, they fell, and so they needed some kind of quick solution before they ended up closing the Kingdom in Seattle. But our material was on the ceiling, and when they imploded the building, and it still stuck to the ceiling substrate. So it's not going to come down very easily.
Thank you, Brian. Do you have a supply in the Middle East? That's the next
Yes,
question.
we do.
Okay. And I guess you would be able to provide.
They can send me an email and I will advance it to the person that handles the Middle East for us, if that's okay. But
Yeah.
yes, I can get them in contact with somebody. Absolutely.
Okay. Thanks, Brian. The next question. What are the warranties and do your system require authorized applicators?
It does require authorized applicators. We only use licensed applicators. And I believe there is a 1-year warranty on the material or the application of the process.
Thank you.
There's a 99-year as far as carbon sequestering and things like that. I mean, as far as the tests and things of the material itself, but the application, I believe, is a 1-year warranty.
Okay, thanks. The next question, how to calculate vapor retarder needs at underside of metal roof deck that already has 2-inch of polyiso insulation?
So I would think that 2 inches, typically, at least what I can gather is a closed cell foam is going to be considered a class 1 vapor retarder at 1.5 inches of material. So if you have 2 inches, you're probably already there with regard to the vapor retarder. And so you don't, that would be, you'd be done with that concern. Now, I guess you would have either, whether it's an acoustic application or a thermal application or a combination thereof, is to get to the appropriate R value that you want as far as the thermal application, and then the appropriate amount of material to do an NRC that you want as far as any acoustic application. But the 2 inches of the spray foam should already get you to the closed, if it's closed cell foam, should get you to the vapor retarder that you're looking for.
Thank you, Brian. We have time for one last question. And that question is, in an older building, does the parking garage ceiling structure need to be power washed before application of your material?
I would do that because you want a clean substrate. And again, in a parking garage, think about it. I know we think of all the dirt that's going to, from the car tracks and things like that, but there's an awful lot of smoke and soot and, whatever. That's why we're trying to go green and get rid of combustible cars. So yes, there's going to be a lot of dirt on that ceiling. And so that it's not, again, that's what's going to affect the bond, is because now the materials that, in that little spot, let's say, is adhering to the dirt and not necessarily the concrete substrate. So it is probably best to have that washed and cleaned, power washed, before you would apply something. That's a good idea.
Thank you, Brian, for joining us today and explaining vapor and thermal barriers. A recording of the demo cast will be available 1 week from now. We will also send a link to the recording via email to all registrants. Thanks to everyone who attended. Before you go, please take a few minutes to give us your feedback by completing our survey. It should appear in your browser after you close Zoom. Have a great afternoon and stay safe.